Okay, so let us understand what is so special about these restriction enzymes. As we know, they are the enzymes that cleave the DNA in between. They cleave the phosphodiester bonds within the DNA fragment. Now, how do they do this? Because we have said earlier discussed that they are very specific enzymes. Specific in the sense we know that exactly where these enzymes will cut in the DNA fragment. So, for maintaining that specificity, these enzymes they have a recognition sequence. So each restriction enzyme has its own recognition sequence, and each restriction enzyme it has own place from where or own set of bases where it will make a cut. Now here you can see in the table that I have labeled here as 6 base cutters and 4 base cutters. Now what do you mean by that? 6 base cutters are the restriction enzymes whose recognition sequence consists of 6 base pairs, whereas 4 base cutters are the restriction enzymes whose recognition sequences consist of 4 base pairs. So for simplicity we use the term 6 base cutters and the 4 base cutters. So in this column you can see some of the examples of 6 base cutters, and here are some of the examples of the 4 base cutters. Now these are the sources of these enzymes, I mean the bacteria from which these enzymes they have been isolated. We have already seen that Hind2 or Hind3 they are isolated from Haemophilus influenzae serotype D. So that's how they are named. Now this column represents the recognition sequence of all these enzymes which are listed here. For example, Hind3 has recognition sequences of 6 bases, that is AA, GC, TT. Now here these arrows you can see in all of them, these arrows they indicate the place where this enzyme is going to make a cut, or then the phosphodiester bond between A and A is going to be broken by Hind3. So if the enzyme makes a cut here and it makes a cut here, we can easily say that it is going to make a going to produce a sticky ends. So if they are sticky ends, they will be having overhangs. So in this example here they have 5' overhangs because it is the 5' end that is going to be overhanging. In the second enzyme Hay2, here you can see the cut is made between C and Y. And in this case it is the 3' end that is going to have overhang. So they are 3' overhangs, right? So similarly in the 4 base cutters you have only 4 bases in the recognition sequence and you get sticky. Now here one example is here, that is the Hay3. It produces blunt ends. As you can see with the direction of the arrows indicates the phosphodiester bonds which are just lie opposite to each other, they are being cut, so producing the blunt end. So that is how the restriction enzymes they recognize the sequence within a DNA fragment and make a specific cut.